Exercise 13.3, fifth question. The question is this. A container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. A container shaped like a cylinder full of ice cream. The ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. That means a cylindrical shape, a cylinder full of ice cream is transferred into a cone with a hemisphere here. So what you have to find is how many cones are there. How many cones are needed to fill all the ice cream in the cylinder. So what you have to do is actually the volume of this cylinder is equal to the number of cones into the volume of that cone. So what you have to find is number of cones. So we have to suppose that let n be the number of cones. N be the number of cones. So what is given as cylinder? Diameter 12 centimeter, radius 6 and height 15 centimeter. Cone, height 12 centimeter, diameter 6 centimeter, that means radius is 3 centimeter. What you have to find is the number of cones. For that we need volume of the cone pi r square h, which is equal to pi into 6 square into 15 centimeter cube, and volume of one ice cream cup is equal to volume of the cone plus volume of the hemisphere, because one cone with a hemisphere. So volume of the cone plus volume of the hemisphere, which is equal to 1 by 3 pi r square h plus 2 by 3 pi r cube. These two r's are different. This is 6 centimeter and this is 3 centimeter. From here we are taking 1 by 3 pi out. So 3 square into h. 3 square into h plus 2 into r cube. R is 3 itself. So let n be the number of cones. The number of cones. So n into volume of the ice cream cup is equal to volume of the cylinder. So what we can do is n into 1 by 3 pi into 3 square into 12 plus 2 into 3 cube is equal to pi into 6 square into 15. So we can cancel off these two pi's. So what we can do is n into 1 by 3. We can take out 3 square from this into 3 square bracket. What is remaining? 12 plus from here 2 into 3, because we have taken out 3 square from that. So 1 3 will remain, is equal to 6 square into 15. So we can cancel off 1 3. So n into 3 into 12 plus 6, that means 18, is equal to 36 into 15. So 3 1s are 3, 3 5s are 15. So n is equal to 36 into 5 divided by 18, which gives 18 1s, 18 2s, 10. Therefore, the number of ice cream cups or number of cones is equal to 10. 10 cones are there. Next question. How many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimensions 5.5 centimeter by 10 centimeter by 3.5 centimeter. Coin means it has some thickness. So, it is actually a cylinder. So, we are taking the coin as a cylinder. So, volume of the silver coin is pi r square h, where r is equal to 1.75 divided by 2 centimeter and thickness 2 millimeter. That means the height is 2 millimeter. Height is equal to 2 millimeter, which is equal to 2 by 10 centimeter. So, what you have to find is the number of silver coins. So, let n be the number of coins. So, n be the number of coins. So, the relation is n into volume of the cylinder or volume of one cone is equal to volume of the cuboid. N into volume of one coin is equal to volume of the cuboid. So, n into, what is the formula? Pi r square h, 22 by 7 into 1.75 divided by 2 whole square into 2 by 10 is equal to 5.5 into 10 into 3.5. You have to find the value of this n, and which you will get as 400. You have to solve this. Do it as homework. Then the last question, 7th question. A cylindrical bucket 32 centimeter high and with a radius of base 18 centimeter is filled with the sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. So, cylindrical bucket full of sand is, what is happening is emptied on the ground as a conical heap. So, cylinder is changing as cone. So, no loss or no gain. So, it is volume of the cylinder is equal to volume of the cone. So, height is given as 32 centimeter and radius is given as 18 centimeter. Here height h1 is given as 24, r1 you have to find, slant height you have to find. So, what you have to use this? You have to use this relation. Here you have to use r1 and r2 because both the radii are different. So, one is r1, other is r2. Same way h1 and h2. So, what you can do here is we can cancel out both the pi's. And r1 square 18 square into 32 is equal to 1 by 3 into r2 is what? This is h2 and r2. r2 you have to find, h2 is given as 24. So, from here you can find r2. Then after getting r2, what do you have to find? Slant height L, root of h square plus r square. Remaining you have to do as homework.